Dear students, warm welcome to today's online session. So the topics to be covered in this online session are Intercloud resource management. So this is the cloud computing topic, Intercloud resource management. The topics to be covered in this chapter, Intercloud resource management, are what are various cloud computing services irrespective of existing one. So there are three cloud service providers in the existing one: IaaS, SaaS, and PaaS. So beyond that, so there are three more cloud service providers or cloud service layers are there. Those considered as a extended cloud services, cloud computing services. These to be discussed. And so what are various resource provisions for deploying the application over the cloud? We will discuss. And how to create a virtual machine and how to manage a virtual machine will look in this video session. And finally, the session will be concluded with the last topic, global exchange of cloud resources. So various resources, how they will exchange the resources or data through the cloud computing in a global manner. We will discuss these four topics in this chapter now. Now let us move to the intercloud. So here there are three different types of clouds, namely single cloud, hybrid cloud, and intercloud. So as we are well aware of what is private cloud and what is public cloud and what is hybrid cloud, these clouds we already discussed. So private cloud in the sense, so anyone having the end users are having um, having rights to utilize or to host the cloud service providers. Anyone can access the cloud service providers, that is called as a public cloud. Private cloud is nothing but an organization or a government organization or any company, they want to host or they want to maintain their own cloud in their own premises, that is called as a private cloud. And hybrid cloud in the sense, so it is the combination of both private clouds and public clouds is considered as a hybrid clouds. So we are well familiar with single cloud like private cloud and public cloud, and also hybrid cloud also we discussed in the earlier class. Now we move to the new cloud, namely intercloud. What is mean by intercloud? Intercloud is nothing but, so the cloud of cloud. Intercloud is the concept of cloud of cloud, is nothing but a intercloud. The intercloud was introduced by Cisco Software Technologies in the year 2008, but it is came into the market with a well-known structure in the year 2015. So here, intercloud is nothing but cloud of cloud. That means that so we can share the resources with the two or more clouds with the help of the networking. So with the help of the storage or with the help of the some other resource management. That means that the resources, the resource management can have an interaction between two or more clouds is nothing but a intercloud. Suppose let us see the diagram here in the intercloud. So there are two different public clouds and two different private clouds. So these different types of private clouds and different types of public clouds can be well connected through a network. That means that here the different types of clouds are sharing the network internally, that is called as a intercloud computing. So now discuss the definition of a intercloud computing. So the definition of intercloud is is it is a network of clouds. That means that intercloud is a network of cloud. That means that cloud of cloud. So that are the network of different types of clouds are linked to each other. So that means that there is a well network connection between private cloud, different types of public clouds, or different types of hybrid clouds. So these different types of clouds can be linked to each other by using a common platform like a networking, or by sharing a resources of storage, or some other is known as a intercloud computing. This intercloud computing includes private clouds, public clouds, and hybrid clouds that came together to provide a seamless exchange of data. That means that finally I can say that intercloud is nothing but share the resources like networking, data, or storage over over private, public, and hybrid different types of cloud is known as intercloud computing. So the intercloud computing is the term which was introduced in the year 2008 by Cisco Software Technologies in United States, and later on it was developed or deployed in IEEE, stands for Institute of Electrical and Electronics Engineers. So it was launched in the market in the year 2008, but it was introduced and successfully utilized by the cloud users or end users in the year 2005 only. So most of the cloud platforms will be pay as use services providers. They are not providing intercloud services with free of cost. They will charge amount for providing the services to the end users. That's why most of the intercloud platform providers will provide the services to the end user, pay per use only. So based on the flexibility, it can provide an opportunity to the clients to manage the cost effectively. So that means that the services will be paid services they are offering to the end users based on the demand. So they will provide the services to the end users. So the main advantage of intercloud computing is so portability and migration. So these are two terms. So these are well-known advantages of intercloud computing. Portability in the sense, so we can have the end user or the customer is having rights or privilegation for moving one cloud service provider to other cloud services. When they are portable from one cloud service provider to another cloud service provider, if the customer or end user is not satisfied with the services provided by existing cloud service provider, so he is always looking for better cloud service providers. If any one of the cloud service provider will provide better services with low cost, with the same configuration and same infrastructure and same platform, in this case, the end users or cloud developers simply move from one cloud service provider to another service provider. So, with the help of the portability. So, portability is one of the advantage of intercloud service technology. Another one is migration. So migration is nothing but we can mixing two or more migrate one cloud with another cloud because of lack of resources. Sometimes we need to host our application in a X or Y cloud service provider. So we are not satisfied with the cloud service provider. We need to migrate the services what we require with the other cloud service providers. In this case, two or three different private or public cloud service providers will migrate their services and they can provide a bulk of provide services to the end users for increasing their business. So here the data could be becomes as simple as dragging and dropping from one provider to the next provider. This will save, that means that whenever we apply portability or migration in the intercloud technology, So this would save lot of time, lot of money, and lot of resources. No need to maintain resources, all the required resources in one particular phase. So finally, I can say that where we are using Intercloud is nothing but, so whenever you are or the customer or the end user, so lack of resources with a particular cloud service provider, he has to approach Intercloud. So by fulfilling their requirements, that is called as a Intercloud technology. So here the topic is Intercloud resource management. We already discussed what is Intercloud. Next, we will discuss about resource management. What is mean by resource management? So resources in the sense here, a computing is a resource, a storage is a resource, a network is a resource, and energy is a resource. These are resources. These resources are maintained by the cloud service providers like Amazon or Google App, Google Clouds. So these are cloud service providers. They are maintaining resources like computing, storage, and networking, and energy resources, not limited this both only. So how to manage, how we can manage these resources, we will see in this topic now. So resource management is the process of allocating a computing in the sense storage, network, and energy resources to, we can apply these resources to a set of applications, set of applications in order to meet the performance objectives and requirements of the cloud service providers and cloud end users. That is known as resource management. Resource management. So basically, what is the requirement of cloud user and what is the requirement of cloud service provider? Always the requirement of cloud user is, he has an application, he wants to host in the application in a cloud uh, by providing all the requirements, by fulfilling the requirements like infrastructure, platform, and runtime environment. If what is the requirement of cloud service provider? The requirement of cloud service provider, he has to ensure that always providing better services or required services to the end users. If he is lagging, he is unable to maintain the required services to the end users, what they are looking for, he has to manage the resources in a stricter manner. So that means that management is a one of the important tasks for resources over the period of time in the terms of cloud service providers and cloud service end users. So here the cloud service providers or end users will have a knowledge on resource management. So by utilizing the resources of computing, storage, networking, and energy resources. So next we move to another topic is cloud service, cloud computing service extended models. So basically, there are three types of cloud services or cloud service models, namely infrastructure as a service, platform as a service, and software as a service. So these three are standard, well familiar cloud computing services. We all are discussed these topics in the earlier class also. So apart from these three, there are three more cloud computing service providers. These considered as a extended cloud service providers. So extended cloud services. So the extended cloud services are namely hardware as a services, network as a services, location as a services. So the hardware as a service, network as a service, location as a service, these are beyond the standard cloud service providers like SaaS, PaaS, and IaaS. So here the IaaS is also having some division of communication services like communication services and data services. So totally there are 6 cloud computing services or layers available, ranging from hardware as a service, network as a service, location as a service, and IaaS, infrastructure as a service, platform as a service, and finally infrastructure as a service. Now we will discuss these 6 cloud services. So in this diagram, now consider this diagram. There are 3 standard cloud computing services. So always the topmost one is software as a services, which can be placed on the top of platform as a service. So here the platform as a services will sit on the top of the infrastructure as a service. The infrastructure as a service will have some 3 subdivision services, likely computational resources IaaS, data as a services like related to storage data, and communication as a services CaaS. These 3 are internal services provided by the infrastructure as a services. So apart from these 3, there are 3 more extended cloud computing services are available. Namely, if you consider the bottom one is hardware virtualization cloud services, which means that providing the link or communication between various hardware components over the network, that is called as a hardware cloud computing services, and network cloud computing services. The NAS stands for network cloud computing services, which can be placed on the top of hardware. And the last one is the location as a services. Location as a services is in the sense, so identifying the location or the geographical area view of data centers which are hosted in different places. Now let us discuss these 6 extended cloud service providers in detail here. So here you consider the cloud platform always provides 3 well standards services, likely platform as a services, the platform as a services which sits on the top of the infrastructure as a services. So here the cloud infrastructure layer or service model, the cloud infrastructure layer can further subdivide it as 2 more cloud service service software as a cloud services, namely storage as a services, or other name is data as a service, and communication as a service. In addition to that, we can compute and storage the infrastructure as a service. These 3 considered as a subdivision of infrastructure as a services. So here the bottom 3 layers, likely the green, the bottom 3 layers, the yellow shaded one is the bottom layer, namely hardware as a services. These are more related to physical requirement. The bottom most layer provides hardware as a services, which can provide the required hardware so to the end users. And on the top of hardware as a services, we can keep network as a services. This is the next layer for the interconnecting all the hardware components, and simply we can consider this one as the network as a services. The best example for network as a services is a virtual LAN. If you consider a virtual LAN, which is not actual LAN, so we can create this virtual LAN in the virtual machines by connecting the network, by using the networking, we can connecting various machines. So finally, virtual LAN will be established in the NAAS, network as a services. This is the one of the cloud service provider, one of the cloud service. And the last one is LAAS, stands for, this is the location as a services. This is the next layer up, offers the location as a services, which can provide the services to the end users by providing the security and providing the power to the physical hardware and network resources over the period of time. So finally, we can say that there are 3 more extended cloud computing services are available in respect of the existing 3, namely LAAS, HAAS, and NAAS. So now here in this graph, in this diagram, we will discuss the layers of cloud services and the cloud service providers. So here the service cloud service is HAAS, hardware as a service. The hardware as a service will be provided by the one of the cloud service provider, namely VMware, virtual machine where VMware is one of the cloud service provider will provide the hardware as a services to the end users. And also Intel is also one of the cloud service provider, and IBM is also familiar, and Gen Enterprise. These four are well-known cloud service providers will provide the hardware as a services to the end users. And coming to the networking as a services, the networking as a services will be provided to the end users by the cloud service providers. Well-known cloud service providers are AT&T. AT&T is the laboratory which is available in the United States. They are they are providing the cloud services to the end users like networking as a services. And above net is also another familiar cloud service provider. And next one is location as a services. This type of location identification services will be provided to the end users by the well-known cloud service providers, namely Internam and the Digital Reality Trust, the 365 main. So these are well-known cloud service providers. And also these three well-known cloud service providers, cloud services like infrastructure as a services. The infrastructure as a services will provide to the end users with the help of the some cloud service providers like AWS. AWS is the cloud, Amazon Web Services Cloud, and open source cloud. Open source cloud stands for open source cloud, and IBM Ensembles is another cloud. Rackspace is one of the familiar cloud. Microsoft Windows Azure also another cloud service provider. HP is also another cloud service providers. So these are well-defined or well-known cloud service providers which are offering infrastructure as a services to the end users. And next, move to the past platform as a services. Platform as a services is one of the cloud computing service. These cloud computing services, platform as a services, will be provided to the end users by a familiar cloud computing providers, namely IBM Blue Cloud, eBay, Microsoft Azure, Facebook, and Google App Engine, and Force.com. So Force.com, NetSuite, these are well-known cloud computing service providers which are providing software platform as a services to the end users. And the last one is software as a service. So the software as a service so can be provided by the cloud providers to the end users like Teleco, Kenexa, WebEx, Salesforce.com. So these are well familiar cloud service providers which are providing software as a services to the end users. So WebEx, if you consider the WebEx is the online meeting, so they are providing the software. They have been developed. WebEx will be developed software as a services to the end users. Next, we move to another one is cloud computing services extended in three different cases. So here, the cloud players are divided into three classes, namely that means that cloud computing services like infrastructure, platform as a service, software as a services, these can be effectively utilized by three players, cloud players, namely administrator, IT administrator. Simply, we can consider as a cloud providers like IBM mainframes, like Microsoft Azure Cloud, Amazon Cloud. So these are considered as a cloud providers. And the second one is cloud player is vendors. Vendors in the sense software developers. Here we can consider as a vendors. And finally, the last cloud player is a end user. End users are customers. So now let us consider the first one is the customers. So end users. So what is the relation between end user with the IaaS? How the end user will select an IaaS? What is the relation between end user and the infrastructure as a service? So always the developed applications will be deployed and stored to provide in the infrastructure as a services. He require infrastructure as a services. Whenever the end user wants to deploy or store his developed application, or he wants to host his application, he wants to deploy his application, developed application, he wants to store his developed application. So into the cloud, he need infrastructure as a service. Infrastructure as a service. The end users to develop and test the software, he need platform as a services. Whenever the end users use the software or business software, he simply host his software as a services. He has to access. Next one is software developers. So the software developers are looking for infrastructure as a services for deploying or storing storage their data. So whereas the software developers looking for platform as a services for enabling their applications via enabling platform for configuration application programming interfaces. And the software developers are vendors looking for software as a services for develop or deploy their developed softwares in the market. And finally, the cloud providers or IT administrators will have an interaction, will select looking for infrastructure as a services for monitoring the SLAs and for monitoring the SLAs and enabling the services. So they are looking for platform as a services. Always the cloud service providers will looking for software as a services to the end users for deploying the softwares. Next, cloud service tasks and trends. So we have seen various cloud service services like platform as a services, software as a services, and infrastructure as a services. Their trends and tasks will be discussed in this session. So here the CRM, so stands for Cloud Resource Management. They are offering software as a services is the first on the cloud computing successfully. So they came into the market. So software as a services. The software as a services will provide tools and also apply to the distributed collaboration and financial and human resource management. With the help of the two tools, they will apply their financial resources or management to the distributed collaborations. And the next one is platform as a services. The platform as a services is provided by the Google. So Google will provide platform as a services to the end users. Salesforce.com will provide platform as a services to the end users, whereas Facebook is also providing a platform as a services to the end users for providing or hosting their applications in a platform. And infrastructure as a services. Here, Microsoft Azure, and Amazon AWS, rack space, and some other cloud service providers are providing infrastructure as a services to the end users. And next one is co-location. Co-location is nothing but location as a services. Location as a services is required multiple cloud service providers to work together to support supply chain in manufacturing. So whenever we are manufacturing a particular service item, so we need to collaborate, we need to integrate with a lot of migrating to the lot of public or private or hybrid clouds. So to overcome the problem, we need to place the services over a period of time in different locations. This is called as a co-location services. And next one is the networking clouds. So the interaction between various clouds through the networking is one of the important tasks. The network cloud service provides the communication between different clouds, and such as AT&T is also one of the cloud service provider, and AboNet is also another cloud service provider. These are providing networking cloud services to the end users. And next, we have seen cloud computing services and extended cloud computing services beyond three standard cloud computing services. In the last slide, next we move to another one is resource provisioning and platform deployment. So resource provisioning and platform deployment means provision of resources. That means that based on the demand, the resources are effectively utilizing or not utilizing, that will be depends on the resource provision. So the resource provisioning in the sense, sometimes the utilization of the resources will be more on demand. Sometimes it is less on the demand. Sometimes it is very low on the demand. That means that the resources allocation is over provision sometimes, under provision sometimes, and constant sometimes. Suppose I have a requirement. So I have a demand. So suppose I need to access 100 customers at that time. Suppose if the number of customers are more number of customers want to access the same data at the same time. So the demand is very high. So at that time it go for over provision. If less number of persons interact with the cloud, the demand is less. That is called as a under provision. So sometimes I need 100 members to access the cloud. So cloud capacity is also 100. That means that so constant provisioning. There is no fluctuation at all. It is a constant provisioning. So that is called as in so maintaining the resources and capacity in a constant way. That is called as in constant provisioning. So in the sense over provisioning in the sense so within the peak load sometimes the cloud computing the cloud machines are running with peak loads or many peak loads. So with the peak load will cause heavy resource wastage. Heavy resource wastage. Whereas the under provisioning, sometimes the cloud machines will run with under provision of resources, which resulting in a loss of both user and providers, cloud service providers resources. So in that the paid demand by the users is not secure, and there is a lot of wastage of resources still exist for those demand areas below the provisional capacity. Sometimes we are looking for constant provisioning. So in this constant provisioning of resources, the resources are running with a fixed capacity to the end user based on the demand, and the result even the resources are not wasted in this case. So here we can compare over provisioning, under provisioning, and constant provisioning. This is the over provisioning, this is the under provisioning, and this is the constant provisioning. So here the demand will reach the maximum capacity, that is called as a over provisioning. Here the demand is sometimes less and sometimes more than the capacity, that is called as a under provisioning. Here it is a constant, so the demand will be constantly decreasing below the capacity, that is called as a under capacity. Next, resource provisioning methods. So for maintaining based on the demand, we need to add or we need to remove the resources over the period of time for maintaining the requirement for the to the end users. So the resource provisioning methods here we need to apply for for stable resource management, providing resource management to the end users. There are three different types of resource provisioning methods, namely a demand-driven method, event-driven method, popularity-driven method. Here, the demand-driven method, in the sense, it will provide static resources and has been used grid computing for many years. So, based on the demand, we need to provide or we need to increase or decrease the resources and to the end users, that is called as a demand driven method. It always works on the demand driven method only. So most probably this has been implemented in the grid computing. If the demand is more, we need to add more grids to the more clusters to the grid. If the demand is less, we need to remove the existing clusters to the from the grid. So here next one is the event-driven method. Event is nothing but it is a trigger. Any situation, sudden situations, an event will be occurs. The event-driven model is always based on predicted workload by the time. The predicted workload by the time is nothing but sometimes the workload on a particular machine is very high. Sometimes the workload on a particular machine is very low. That is mainly based on the event-driven methods. And another one is popularity-driven method. So popularity-driven method is based on the internet traffic monitor. Internet traffic monitor. Sometimes the virtual machines is running with huge traffic. Sometimes the virtual machines is running with less traffic, sometimes the virtual machines are running with idle traffic. So that means that the scalability is one of the important factor for maintaining popularity driven method over the period of time. So we need to scale down automatically and scale up automatically the resources for maintaining the popularity driven method over the period of time. So let us discuss with the first resource provisioning method, demand-driven resource provisioning method. So one of the best example for this demand-driven resource provisioning method is Amazon. So Amazon AWS. Amazon Web Services is the cloud that can implement auto scale up or scale down feature in the EC2, Elastic Cloud Computing 2 platform. So if you observe the Amazon Elastic Cloud Computing 2 platform, so the demand of the resources will be automatically increased or decreased by auto scaling feature. This is implemented by the Amazon Web Services in the market. So this demand driven resource management provisioning method will help to the end users by adding or removing the cloud computing instances with the based on the utilization level and allocated resources over the period of time. So the current utilization level of allocated resources will be automatically scale up or scale down based on the demand driven method only. So the demand driven method automatically allocates the processors to the end users. So basically the basically the virtual machine is running with one processor. So if the processor name is Geon processor, if the virtual machine will reach 60 percentage of time period, that means that what the virtual machine processor will reach 60 percentage of their processing time, then only it will send one request to the end user, cloud service provider, add one more processor for running. There is a huge demand, it will send one signal. So then only we need to add one more processor to the existing one. That means that it will automatically allocate two Geon processors for the user applications when the user was using one processor more than 60 percentage of time for extended period of time. This means that finally I can say that when we are going to add another processor to the existing processor is if the processor is running with 60 percentage of load, when the processor is exceeding the 60 percentage of capacity, automatically it will send a request to the provider. The cloud service provider will automatically add one more processor by scale up automatically. So this is called as a demand, based on the demand revision method. And when the resources has extended, so there is a threshold value. So when it will be reach the threshold value, automatically the resources need to increase. When it is below the resource value, the threshold value, the resources will be automatically scaled down. So this will be decrease the resources accordingly. So the resources increasing, the resources decreasing can be mainly based on the basic requirement as a threshold value. If the demand is more than the threshold value, we need to increase the resources. If the demand is below the threshold value, we need to decrease the resources. Here, the threshold value is considered as a 60 percentage of utilization of the resources. Whenever the 60 percentage of utilization of resources is reached, it will more than the resource more than the threshold value, automatically the resources has exceeded. Otherwise, the resources has been below the resources. And next one is event-driven resource provisioning. So event-driven resource provisioning, this type of scheme will automatically add or remove the instances. This can be done basically the event-specific time. It will be done suddenly, event-specific time. During this event-specific time, the number of user growth or downfall will be mainly depends on event specific time only. So it will be the number of users will grow before the event period and the number of users decrease during the event period. So this scheme anticipate the peak traffic before it happens, and it results the minimum quality of services if the event is predicted correctly. So otherwise, if you're not maintaining, the wasted resources are even greater due to events and do not follow a fixed patterns. So next one is popularity driven resource provision. So the popularity driven resource provisioning, this scheme anticipates increasing the traffic with popularity. The traffic over the particular machine will be automatically scale up, scale down. It is mainly based on the traffic imposed on the server only. So again, this scheme has a minimal loss of quality of services if the predicted popularity is correct. The resources may be wasted sometimes if the traffic does not occur as expected requirements. So basically, these three driven resource provisioning methods are required for stabilizing in the market, like popularity, event, or demand driven. So next we will see the architecture of cloud resource deployment using integrated gateway. So we have a cloud application. I want to host a cloud application into the cloud. Let us discuss this diagram once again. Suppose an end user or a customer having a developed application with him. He wants to host his application into the cloud. For that, he is looking for cloud service provider who is offering the services like platform, infrastructure, and software as a services. So once he has selected the cloud service provider, the end user will simply host the developed application into the cloud with the help of the internet. So meanwhile, here the cloud deployment to the end user side will interact with the integrated gateway. So here the end user is having a developed application with him. He wants to host his developed application either in a cloud or either in a physical resources, that means a local desk, or in an organization site. He has three options. One is the end user wants to host his application, developed application in the cloud, or the end user wants to host or save his application into the physical resources, local machine. Either the end user wants to host his application into the organization site. So he has three options. Let us see if the end user wants to host his application in the physical resources in his internal memory, he can directly save or host the developed application into the physical resources, into the cloud. So no need to bother about the cloud. Another one is if the end user wants to host his developed application in the cloud, so he has to interact with the virtual interface engine, cloud virtual interface engine. Through that he has to deploy the cloud resources can be deployed using IgG. IgG stands for intergrid gateway. The intergrid gateway will take the input from the cloud service provider, from the user or end user. The integrated intergrid gateway takes the request from the end user, and it can pass the request to the another intergrid gateway through the peer in one-to-one communication, and it can pass to the VIE. That means that virtual integration cloud computing API. Through that, they are hosted their services to the end providers, cloud service providers. So the end user wants to kept or host his application in the cloud, he has to first send a request to the virtual machine. Here, the intergrid gateway will take the request of virtual machine and processing the request through the cloud application program interface, and the application is to be hosted into the cloud. This is one methodology. Another one is whenever the end user wants to deploy the resources in the organization site. So in the private cloud, through private cloud, he wants to host, he will send a request. The request can be processed by integrated gateway, and it can be processing through virtual infrastructure engine, VAE. The virtual infrastructure engine will process the request and it can be posted into the organization site, physical resources. And whenever the end user wants to deploy his application into the local machine, he can directly store his application into the local machine. So he has direct access to do the application into the local machine. He has he wants to host his application into the cloud computing through virtual infrastructure engine, and he wants to host his application into the organization side through the virtual infrastructure engine. Here, the cloud resource deployment will be using an integrated gateway to allocate the virtual machines from your local cluster to the interact with the IGC of your public cloud services. So if you consider the provisioning of your storage resources, there are three cloud computing systems offered for storage services. Here, the distributed file systems, DFS stands for the distributed file systems, storing for large scale of data. If you want to store large amount of the data, we use the distributed file systems. In cloud computing, the another form of storing data is key pairs. Through key pairs, the data will be stored in the database through key pair. Here the key pair is key and value. Key is the unique value and it is pairing with the value, the unique ID pairing with the value. Here, the Amazon S3 is one of the cloud service provider. They are providing services to the end users with the help of the SOAP and object stored over the cloud. Here, there are three types of cloud service storage systems are available. One is we already know that Google file system or distributed file systems. We already discussed here. Google file systems is used for storing lot of amount of the data. And HDFS, Hadoop distributed file systems is providing storage system, and Amazon ES3 and EPS. So these are three well-defined storage systems for providing services to the end users for storing large amount of data. The Google file systems will be used for storing or keeping very large amount of data. Very large amount of the data they want to store in their virtual machines. We use GFS, Google file systems. So Hadoop distributed file systems, this is an open source file systems. They can written in Java. This type of APIs will be used for providing Hadoop distributed file systems. And Amazon is also another cloud service provider for providing for storing a lot of data. So here the Amazon S3 is used for retrieving or storing lot of data from the remote server or to the remote server. Whereas the EPS is also another cloud, Amazon EPS, which can be used for built on the top of the Amazon S3. This is used for virtual disks running in elastic clouds to instances. And let us move to another topic is how to create virtual machine and how to manage virtual machines. Now first we will discuss about why we need to create virtual machine. So the virtual machine creation is important nowadays in the cloud computing scenario because day by day the usage of or the hosting of services over the cloud is increasing rapidly in the past 10 years, decades. In this manner, we need to provide the well-known services to the end users. We need to create or set up virtual machines in different locations or remotely. So for providing software as a services, infrastructure as a services, and software as a services to the end users. So virtual machines is nothing but it is not a machine. It is a machine can be created in the virtual manner with providing lot by adding the resources like storage, networking, or power, or some other. So here, the virtual, if you consider the diagram here, there is a virtual machine manager. The virtual machine manager provides a public API, public application programming interface services that are providing to the end users to submit and control the virtual machines. The virtual machine submissions and controls can be done by the virtual machine manager, and the virtual machine manager using one of the open Nebula the manager using the Open Nebula. This is the one of the operating system which can be used to deploy multiple virtual machines on a local cluster. And also this virtual the manager using another infrastructure as a services for providing services to the end users. And the manager, the virtual machine manager will provide emulator for sending the request from the one machine to the other machine. So here there are three different types of layers: local physical infrastructure, grid 5000, and Amazon EC2, Elastic 2. The Amazon EC2 is running with a collection of different virtual machines, and here there are a set of local physical infrastructures. This is also considered as a virtual machine, and grid 5000. There are various locations the virtual machines will be placed in different remote locations. These are well connected through a grid networking that is considered as a grid 5000. These three are considered as virtual machines which are based in three different locations. We can provide the communication. We can create the virtual machines in remote locations with a set of networking components, set of data components, set of storage components, and set of some other power components. So here, if you consider the template of the virtual machine directory, always the template of virtual machine will be looking for the storage capacity and the operating system capacity, and then the networking capacity, which type of networking is required, which type of storage is required, and which type of operating system is required. So these different types of operation system, different types of storage capacities, and different types of networking can be maintained by the different virtual machines. So the virtual instances will submit a request to the virtual manager. The virtual manager will provide a public API for the end users to submit and control the virtual machines. So here the manager will be using Open Nebula operating system to deploy the virtual machines in the clusters, and in this way the interaction among virtual machine managers for the cloud creation and management will be clearly seen in this diagram. So next, the last topic is global exchange of cloud resources. So cloud resources is nothing but how effectively we are utilizing the resources like software, hardware, and storage and power. These are the resources, computing. So these resources sometimes we need to exchange globally from one virtual machine to another remote virtual machine through the network. So that is important nowadays. Why? Because suppose let us take an example. Microsoft Amazon is there. Amazon is maintaining a virtual machine in two different remote locations, namely Europe and United States. They are maintaining one virtual machine in Europe country, and they are maintaining the same virtual machine in some other country like Europe. Suppose a person or an end user wants to host or deploy his developed application in a cloud, he has to look nearby cloud. Nearby cloud means India, but there is no virtual machine is maintaining by the India. Amazon is not maintaining virtual machine in India. Assume that. In this case, a customer from India wants to host his applications into the cloud, which is located the virtual machine in US or Europe-based company, he has some doubts whether it is reliable, it is safe. So to overcome the problem, so he has to deploy one more virtual machine in India and with a limited set of resources. Whenever the Indian located virtual machine running with different resources, then only so we can the resources exchange or the resources globally through the network. It is possible. That means that the resources can be accessed or exchanged globally based on the requirement of the customer or end user. In addition, a single cloud computing, a single cloud provider cannot provide infrastructure to the end users by establishing data centers all possible locations throughout the world. It is not possible. Providing data centers to the end users in different locations with all resources is not possible. But how it is possible? As a result, what will happen? Cloud application services like SaaS will have difficulty in meeting quality of services expectations from all their customers. So here, the requirement is not meeting. To overcome the problem, what to do? Hence, they would like to make use of services of multiple cloud infrastructure service providers who can provide better services to the end users. That means that there are three different virtual machines located in India, Europe, or US based companies. But no need to maintain all services required in a particular virtual machine. So the virtual machines is running with different virtual resources, but whenever the customer wants to host his application in particular virtual machine, so the virtual machine automatically integrated together, automatically scale up or scale down the resources they are sharing or exchanging the resources globally, so they can provide the required software, required platform, required infrastructure to the end users by exchanging their resources globally. So this kind of requirements often rises in enterprises with the global operations and applications such as internet services, media hosting, and web 2.0 applications. Let us consider a simple diagrammatical view how intercloud exchange of cloud resources can be done through a brokerage or brokering. So here, a person, there are different types of persons, namely a broker one and broker N. That means that n number of broker. Broker will be acted as an intermediate person. He can provide an agreement between two different parties. Here the parties is one is enterprise or the consumer party. Here one is enterprise IT consumer. Consumer in the sense end user. A company or a end user is considered as a one person is another one is cloud service providers. Here the cloud service providers are providing some services like computing cloud, storage clouds. Different computing clouds are listed here, different storage clouds are listed here. Whenever the consumer wants to host his services over a storage cloud or a compute cloud, he cannot interact directly with the computing cloud or storage cloud. So he has to communicate the storage cloud or compute cloud through a broker that is called as a global cloud exchange. Here there are various n number of brokers. The broker will take the request from the cloud cloud consumer or end user. He can take the request and the request will be sent to the global exchange clouds like bank, auctioneer, or dictionary. The banks will put one bid or the auctioneer will put one bid. So they can take the a request from different clients, and they can whenever the client will reach the bid, automatically they will publish their request over the computing cloud or storage cloud based on their requirement. That means that they are providing an environment for they exchanging the global resources through the brokering. A number of brokers is there, like auctioneer. Auctioneer is nothing but based on the pay as you user. Suppose, for example, here assume that there are five clients. These five clients are end users looking, posting their developed clouds over the clouds. Here, the cloud service providers will connect it to the global cloud exchange, and they are providing their services to the end users pay as you. They are not providing services free of cost. They are providing their services to the end users by paying or by amount to the end users. So here the end user will have an access for putting a bid over through brokering. So the broker will take the other request, and the broker will communicate their request to the bid authority. The bid authority will go for an auction, and they're finalizing we who is having more highest bid, and they're allocating their request to the bid so and so global exchange. The global exchange will automatically connect providing services to the end users.